Well, like it's '05, so we're going to start our class now. So I guess for icebreakers, we can talk about like what is like your dream job as a kid and like what is your dream job right now, like for the future. So for me, I wanted to be a doctor when I was a kid, but now I want to do something related to math. And I'll pass it on to Hetvi. Hetvi, do you want to share? Oh, maybe Sashi.
Yeah, so when I was like a younger kid, I think my dream job was like being a politician. And like right now, I still do want to be a politician, but I also want to be a lawyer or a doctor as well. And I'll pass it on to Dia.
Um, as as a kid, I wanted to be like an astronaut, but now I want to be either a lawyer or a judge. I'll pass it on to Beatrice.
When I was littler, I wanted to be a pilot, but now I want to be an editor. I'm passing it on to Hetvi.
When I was younger, I wanted to be a teacher, and then now I want to be a doctor. I don't know who went or who didn't go.
Mm, I didn't keep track. Did anyone else not? Oh, did anyone not go yet?
I didn't go yet. Can I share?
Yeah, go ahead.
When I was younger, I wanted to become a doctor, and I still want to become one. So I didn't really change my opinion on that. I think I'll pass it on to Solange.
So when I was younger, I wanted to be a doctor, but now I want to either pursue something in the music field or in computer science.
Did anyone else not go yet? Okay, great. That's a lot of like really cool occupations. So yeah, I guess we can start class today. So today's topic, wait, I'm gonna share screen from. Okay. Um, all right, so today's topic is polynomial division. So I think this was like in very early on in our class. This like on the first or second week, we talked about polynomial addition, which was like multiplication, addition, and subtraction. And today we'll be talking about polynomial division, which gets its very own class. So what does it mean to divide polynomials? It's very interesting, like it's very similar to dividing integers. Like for example, when you divide an integer, you're basically saying that like, okay, division in integers, which in math we write as z, which is like just a way to write integers. So for example, if you have like a over b is equal to c, then this basically says that a is equal to b times c. And then you have like two values, a and b, and you're trying to figure out what c is. And this is basically similar to polynomial division. So you have like p, q, and r, and these are all polynomials. And you want to say like, what is like p over q? And you say that this is equal to r. Then you're basically saying that p is equal to q times r. Okay, so we kind of run into like a problem. So for integers, maybe let's talk about like reals instead, or like rationals. And then rationals, wait, I kind of forgot what rationals. Oh yeah, it was q. Rationals is q. Okay, so if you have a over b is equal to c, then you can write this, right? But the problem with polynomials is that it's not closed. So what this means is that if you have x squared plus 1 and you divide this by x, then you get like x plus 1 over x, right? And you can't really simplify this any further. So this is basically very similar to integers. So like, say you have like 7 over 4, then you write this as 1 and 3 over 4, which is like improper fractions, right? And what this means is that 3 is the remainder, and then, yeah, so in polynomials, this is also the remainder. So whatever comes, like, whatever is above, like, the initial, like, denominator or whatever you're dividing by. So it's basically similar to integers. So first, let's talk about like when it divides evenly. Okay, so division. Um, and it's like, how do we like wait? So there's like two types of division. There's long division and there's synthetic. So, do you guys like do you guys remember what long division is? Can I get like a raise of hands? Yeah, that's a good amount. Okay. So, I guess we can like go over like just as a review for some people. Um, Basically the idea is that if you have like say you're dividing example is dividing x to the fourth plus x squared plus 2x by like 2x plus wait maybe x plus 1. Then you write this out um and you divide this by x plus 1. So basically wait this is like wait actually let's compare this with integers side by side because we said that division is very similar to integers, right? So say let's do like 101,842 divided by like 5. So how does okay, so first step is in integers you do like, oh, does 1 divide 5? Then nope. 1 doesn't divide 5, so you go on to 18, and 18 does divide 5. So you write 3, right? So you can do 15 at most. And then you subtract and you get 34 and 342, right? And then you want to see like, oh, does 33 divide 5? Nope. Or like, does 5 divide 3? Nope. Does 5 divide 34? Well, it's big enough and you can do like 6. So you do that, right? And then you do this again. So does 5 divide 4? Nope. But 5 divides 40. So you have this. And you get a remainder of 2. And this works very similarly with polynomials. So so let's see. So does x plus 1 divide x4 to the fourth? Well, not really. Well, we don't really know that, but we know that it divides something kind of similar to it, which is like you just look at like x to the third, for example. So what happens when you multiply x to the third times x plus 1, you get x to the fourth plus x to the third, right? And this cancels out, so it would be 0, and you have 2x. And does x plus 1 divide 2x? No, but you can take out a factor of 2, so you get 2, and you get 2x plus 2, and then this is negative 2. So we have that this is the remainder when you divide the polynomial. So intuitively, what we're doing like is that you look at each term and then you compare with the first term and you see how many times like you can divide each term. Because doing one term over another term is simple because the x just cancels out. So we can do like an exercise. Yeah, I'll give you guys some time to do it. Okay, so I got the correct answer, so I guess we can go over it now. So what you do first is you like compare the first terms, like the leading term. So x times x, wait, 7 times x to the fifth, you can divide x squared, and that would give like 7x to the third, right? So 7x to the third, and now you can keep, like, you can multiply this by the whole, like, this entire quotient. So you got 7x to the fifth plus 7x to the third. And then when you subtract, you get a negative 3x cubed plus 3x squared plus x plus 2. And you compare this with the leading x squared, and you see that you can multiply it by negative 3x to get, you multiply negative 3x by x squared to get negative 3x cubed. And when you do this, you get negative 3x cubed minus 3x. And subtracting, gotta be careful about the negative signs. You get, and the fact that there's actually a term missing here, and it's not like there's an x squared missing, but you can technically write like plus 0x squared, right? But that's not a thing, so be careful when you're subtracting. So this would be 3x squared plus, okay, so x minus negative 3x, so plus 4x plus 2. And you compare this with this term, so you have to add 3. You get 3x squared plus 3. And again, there's no x term over here. They just treat it like it's plus 0x. So that would be 4x minus 1. And the issue here is that x is like, this degree is less than the degree of x squared, because the degree of x squared is 2, which is like the exponent, right? But the degree of x, 4x minus 1 is 1, right? So you can't do anything. So if we were to rewrite this, then you can say that when 7x to the cube minus 3x, wait, sorry.
Excuse me?
Yeah.
Sorry, but could you explain how you got the plus 4x plus 2? Like how you got that?
So over here, right? So what we're doing, like we're subtracting like this and this, right? So it's a little bit tricky because if we rewrite this, we have negative 3x cubed plus 3x squared plus x plus 2 subtract, so it's like parentheses, right? Subtract negative 3x cubed, and then, okay, so we don't have an x squared here. So it's plus 0x squared, and then minus 3x plus 0. So I guess the terms will line up, right? So this cancels out, and then over here you subtract 3x squared minus 0x, so that would be equal to 3x. And then you subtract x minus negative 3x, and that would be, okay, so that would be 4x, right? Because like when you subtract, okay, when you have x minus negative 3x, this is equal to x plus 3x. And then when you have 2 minus 0, then that's equal to 2. So it should be like that. Does that make sense?
Okay, thank you.
Yeah, no worries. So yeah. So we can basically write that if we have x 7x to the fifth plus 4x to the third plus 3x squared plus x plus 2, and you divide this by 7x, oops, x squared plus x squared plus 1, right? Then you actually end up with this over here, 7x to the third minus 3x plus 3. And then you have this, which is the remainder, right? And you can't really divide x squared plus 1 out of it. But you can only write this as a numerator to a fraction similar to what we had in the beginning. So we write it like this. And you can see that this fraction cannot be simplified. So that's basically how long division works. And it is a bit tedious, but make sure to practice a lot and it'll be good. And because it is tedious, there's actually another method, which is very like a lot of people prefer it more. And you'll see why. So it's called synthetic division. So I guess the best way to show this is to use an example. So let's just use our example here. Is it x fourth plus x cubed plus 2x divided by x plus 1. So basically how we do this is we kind of look at this, the numerator first. So we can write this as x to the fourth plus x to the third plus 0x to the second plus 2x plus 0. Yeah. So what we do next is we only look at the coefficients of the terms. So what that means is like, okay, so this is basically 1 times x to the fourth, 1 times x to the third, 0 times x squared, 2x, and 0, right? So when we write this out, we only write down the coefficients of what you're dividing. So what happens is you have 1, 1, 0, 2, and 0. Okay, and then you look at this denominator, and you have x plus 1, and this is just negative 1. So it's basically, because if you solve like x plus 1 is equal to 0, then it's negative, x is equal to negative, right? So this is x plus 1 is equal to 0. That's when you solve that. And then what you do next is, okay, write 0 here first, and then you subtract 1 minus 0. So that'd be 1. And you multiply 1 times negative 1 to get negative 1. And then, wait, I think you subtract. Where do you add? Wait, yeah. And then after that, I think you, let me see. Oh yeah, you add. So it should be 1 plus 0 is equal to 1. Anyways, it would be 1 plus negative 1, and that's 0. And then you multiply 0 times negative 1 to get 0. And then you get 0 plus 0 is equal to 0. And 0 plus negative 1 is equal to 2. When you add it, it's 4. Wait, hold on. Yeah, I'm pretty sure. Yeah. Okay, so what this means is that, all right, this is 0, sorry. So what this means is that when you divide it, you have x to the, okay, so this becomes like, these are just the coefficients of the new polynomial. And the difference is that over here, the polynomial is of degree 4, right? But since you divide by x plus 1, then you split this into two sections. So the first section is polynomial of degree 3, and then this is the remainder. So when we write this out, we have x to the power of 4, wait, x to the power of 3, plus 0, x squared, plus 0x, plus 2, and then you have plus negative 2 over x plus 1. And you can write this as x to the power of 3 plus 2 minus 2 over x plus 1. And this should match up. I think this matches up with our, yeah, it does. It matches up with what we got from long division. Yeah, it's pretty neat because it's a lot easier and we can omit like the x cubes and like all that. So yeah, let's do some practice.
I have a question.
Yeah.
So, once you're like dividing the coefficients, the numbers under the coefficient, did you like take 1 and multiply with negative 1 and then whatever you got, is that your second number?
Yeah, so you do 1 plus 0 and then you get like 1, right? And you
Yeah.
multiply 1 times negative 1 and you write that over here and then you add them to get 0 and then you multiply 0 times negative 1 to get 0 and that would be your number here. And you just keep doing that.
Okay, but like 2 times negative 1 would be negative 2, right? So why did you put it as a 0?
You mean over here?
No, before that.
Here?
Mm-hmm.
Oh yeah, so we get this number from doing 0 times negative 1 because you're always multiplying the previous number and this last thing by the number here.
And for the first number, are you always supposed to multiply? Are you always supposed to put a 0?
Yeah, you always
Okay.
put a 0 on the first number.
Okay.
That was a
Thank you.
good question.
Thank you.
So yeah, let's do some practice. All right. First of all, does anyone know why sometimes we can't use synthetic division? Yeah, I'll say it. So over here in our example, we use like we divided by x plus 1, right? However, we can see like when we did long division on this example, you could divide by x squared plus 1. And you can't really do that in synthetic division because we're always solving for like x plus 1 is equal to 0, well, what we get there. And for example, for x squared plus 1, well, you can't really do that with like if the degree is like more than 2. I think there's a method, but it's like a little more complicated. So yeah, this is synthetic division. Let's do an example. I didn't do this problem yet, so I don't know if the numbers are messy, but give it a go. Okay, so I think we can go over now. So the first step is always to write out the coefficients. So that would be 3, 6, 9, and 3. And what would we put on the left side? And as a hint, this is like when you solve for the denominator. So you're solving for 2x plus 1 is equal to 0. So what would that be?
-1/2.
Yeah, exactly. -1/2. And that looks like kind of intimidating, but it's actually fine. So, okay, so our first step is to have 0. So when you add it, you get 3, and 3 times -1/2 is -3 halves, right? And when you multiply, or like when you add, get 9 halves, and then you multiply again and you get -9/4. You add them, so you get 27/4, and then you multiply to get -27/8. And then you add again to get -3/4. So does anyone know what the polynomial remainder would be? So this is like a polynomial of degree 3. So this would be a polynomial of degree 2. So this is 3x squared plus 9/2x plus 27/4. And then the remainder would be -3/4. So yeah. I think we can do another exercise just for fun. Let's do 2x to the third minus 3x squared minus 8x plus 12 divided by x minus 2. Okay, so I guess we can go over the question now. I believe the answer to this is 0.9, so 2, -3, -8, and 12. And what would be on the left side? It would be like x minus 2, you solve for 0, so x is equal to 2. Okay, so we start with having 0 over here. And then when you subtract, when you add it, you get 2. And you multiply to get 4. And you add. Yeah, Sashi?
Yeah, I was just wondering if I could like explain it, if that was okay.
That'd be awesome.
Okay. Yeah, so as you said, so then we would put 4, so the -3 plus 4 is 1. So then we write a 1, and then we do 2 times 1, which is 2. So then we add a 2, and then we get -6. And then we do 2 times -6, which is -12. And then we'd subtract 12, and we'd get 0. And since the equation had like a degree of 3, the answer would be a degree of 2. So the final answer would be 2x squared plus x minus 6. And since it's 0, there's no remainder.
Yeah, exactly. So that's perfect. That's perfect. So nice thing about this problem is that there's no remainder, or like it divides perfectly. Okay, cool. So now let's talk about remainder theorem, which is kind of related to this. This is a pretty cool statement. So basically it says that when you when you divide like a polynomial p by say like I don't know, x minus c. The the polynomial p of x, like the polynomial function. The remainder is equal to p of c. So what this says is that say you have like okay, we know that x squared plus like 2x plus 1 is like say p of x is equal to this, right? And when let's say like we're dividing by like x. So this means that c is equal to 0, right? So p of c is equal to 0 squared plus 2 times 0 plus 1 is equal to 1. And we can see that this is true because, wait, we see that this is equal to remainder because when you divide x plus 2x by plus 1, you get a remainder of 1 since the first two terms are divisible by x. And does anyone want to explain why this like is true like intuitively? All right, how about if we build off this and like say, okay, corollary. I think this is called factor theorem. So the definition of factor is that the remainder is equal to 0. Um, so x minus c is a factor of p of x if p of c is equal to 0. And this is a direct like result of our previous of the remainder theorem because if what we just said that like if remainder is equal to 0, then it is a factor. Since so why is this true? Does anyone know why this statement is true? Okay, so this kind of makes sense because like, okay, say x minus c is a factor of p of x. Then say that q of x is another polynomial. Then you can write p of x is equal to q of x times x minus c, right? Since this is like very similar to how integers work. Since x minus c is divides p of x, then you can multiply x minus c by another thing to get p of x. And when you plug in x is equal to 0, then you get p of c is equal to q of c times c minus c. And c minus c is 0, so this is equal to 0. So we can see how the factor theorem is true. So how does that like kind of relate to the remainder theorem? Maybe we reorder it. Well, okay, say that. Well, how can we write like the polynomial in terms of like itself and the remainder? You can say like if r of x is the remainder, then p of x is equal to q of x times x minus c plus r of x, right? Because this is just like a way to like write this polynomial again. And when we have like when we substitute by c, like we substitute c is equal to 0 or like x is equal to c. Then p of c is equal to q of c times 0 plus r of c. So this means that since you multiply by 0, this means that p of c is equal to r of c. So in fact, p of c is equal to the remainder because r of c is the remainder. So yeah, great. And by the way, side note, we know that r of c is actually constant. We know that r is actually constant, so in fact, it doesn't even matter that we write r of x. We can just say r. And does anyone know why r is a constant? Well, this is because you're dividing by x minus c. And whenever you divide something, the remainder has a lower degree. And the only degree less than 1 is 0. And for that to be true, r has to be constant, since only constants have degree of 0. Okay, so for now we can do some practice problems. So exercise. Um, okay. Okay, so I guess we can go over this. So what we can use is remainder theorem, which is what we just did. So when you divide by 3x to the power of 3 minus 5x squared plus 2x minus 8 by x minus 2, what do you plug into the original polynomial? Well, we plug into x minus 2 is equal to 0, so x is equal to 2. And then what happens is like you get 3 times 2 to the third minus 5 times 2 squared plus 2 times 2 minus 8. And when you calculate this, you get, okay, wait, so you get 24 minus 20 plus 4 minus 8. And this is equal to 0. And what does that mean when it's equal to 0? The remainder is equal to 0, which means that x minus 2 is actually a factor of this originally polynomial. Factor of 3x cubed minus 5x squared plus 2x minus 8 by factor theorem, which is what we just had. So yeah, as another example, let's see, is x minus 3 a factor of the polynomial, wait, sorry, x plus 3, or wait, x plus 2, x to the 5th plus 2x4 minus 13x squared cubed minus 14x squared plus 24x plus 48. So I'll give you some guys some time. Okay, let's go over this one. So what does it mean when x plus 2 is a factor? It means that remainder is 0. Which means that if this is equal to p of x, then p of -2 is equal to 0 by remainder theorem or by factor theorem. So we want to find the value of p of -2. And that just means we plug in x is equal to -2. So -2 to the 5th plus 2 times -2 to the 4th minus 13 times -2 to the 3rd minus 14 -2 to the 2nd plus 24 times -2 minus 48. And something cool is that, well, these two actually cancel out because this is positive, and this is negative. And then we're left with, okay, so negative 13 times 8, that is negative 104. And then minus 14 times, wait, negative 2 squared is 4. So minus 14 times 4, that is minus 56. And then you're subtracting 48, and you're subtracting 48 again. And, well, whatever this is, it's not equal to 0, clearly. It's like a very large number that is in the negative. So I guess we can like just calculate it. So it'd be like negative 160 minus 96. So negative 256. And this is not equal to 0. And that means that x plus 2 is not a factor. So cool. So yeah, that is factor theorem and remainder theorem. And since it's, oh, yeah, so since it's 08 or 58, I can let you guys go early. And yeah, thank you guys for coming. See you guys next week.
Thank you. Bye.
Bye.
Thank you. Bye.
Thank you. Bye. Thank you. Bye.